Good morning, everyone. Like we say here, bon matin. I am presenting you this morning this paper. I am Louis-Philippe Kyer. I'm a student in the Masters in Computer Engineering at the Polytechnique, and I'm presenting a large-scale comparison of Python code in Jupyter notebooks and scripts. This is the first and largest comparison that was ever done on the subject. It was presented at MSR in 2022. So on the left here we have the warrior, the fighter, the Python script in the IDE like VS Code. So you can see it's traditional Python code with functions here. And on the right you have a Jupyter notecode, which is a notebook solution for Python code. As you can see, the Python code is in cells here. And these cells can be seen as microfunctions. So you execute them, and the part of that gives you an output at the bottom. And then there are markdown cells too, where there's the title. You can add images, you can add graphs, so it makes presenting data very nice. So I would like to know on your end, what fighter do you choose when you do data science? Do you choose the Python script? Or do you choose the Jupyter notebook? Or maybe you don't choose any of those and you use RStudio or other solutions. Let me know. The authors of this paper actually found that the notebooks have grown greatly in popularity in the last few years because of machine learning and data science, as they are very convenient to present a well-organized code or thesis. Yes. What is the background on this paper? Why research this? So first of all, Python is a top-ranked language. It was the number one ranked language in 2025 and 2024, and it's been in the top 5 for probably a decade at this point. It is widely used in production, so you have big apps like Dropbox, for instance, that are using it in their back end. So that also means there's plenty of open source resources, and there's plenty of data to mine, which is key for this research. Notebooks are great for data, we saw that, but they do change coding practices. We saw that again with the cells here, execution. The common tools used in software engineering, like linters, for instance, error detections, they could be misaligned with notebook code, and this could require adaptation for notebooks. That is the hypothesis that the authors make. So their objective with this research is to gather insights for development of notebook-specific tools. And alert here, these researchers work for JetBrains Research, which also released not too far after this research DataSpell, which is an IDE for data science. So how one such studies and compares Python code? Well, they decided to go with 2 dimensions. First, the structure. So how does the code differ from Jupyter Notebook structurally from Python scripts? And same question, but for stylistically. What we know from previous research is that only 20% of notebooks will execute after cloning. Even less will give the expected result. That is not good. We call that low reproducibility. Another problem with notebooks that were found in previous research is that only 8.54% of notebooks that define their own classes. So that means there's a lot of code duplication in a notebook usually. There's a principle in software engineering that says don't repeat yourself. That's not good. In terms of style, so we're talking extra indentation, names of functions that are not good, uh, variables that are way too long, useless calls. Well, this is all the style aspect, and it's been shown for a while now that low stylistic quality does also mean low reproducibility. It also means a higher percentage of tests failings. So for this research, the authors, they built here this pipeline. So they started with source data. It all comes from GitHub. For the public project, for the notebook files, what they did is they used the GitHub API and they targeted all the projects that were public and that had .ipynb files, which are notebooks, Python notebooks. And they extracted all of those projects and they extracted all of the notebooks from those projects. So they ended up with 8.4 million notebooks. Now they wanted to make this data set that they're gathering public for us, available for research. So they looked at all the notebooks and verified that the project had a permissive license. So they did that for all of them, and they did them with almost 10 times less. So 847,000 notebooks. For the Python scripts, well, there's a lot of, you can imagine, Python projects on GitHub. So they used a tool that was developed and presented at a former MSR called CART, which has a database of 2021. At the time, it was recent for the research that it was in 2022. And using this kind of index or database, they search for the top 10,000 Python projects with most stars. They also looked at the same time for permissive licensing. From that, they extracted from GitHub 465,000 scripts. So it's a pretty decent data set. After that, they processed it and they created reports that we will see. In terms of analysis and processing, well, structural analysis is a well-covered area of research. There was previous research done that provided, for instance, 300 metrics to analyze software code. So the authors chose 15 of those, and they targeted code complexity and maintainability. Tool exists for analysis of Python scripts, but not for notebooks. So the team, they had to build a software called Matroskin. It's a library that is specialized for notebook structural analysis. So quickly, why did they need to do that? It's because, for instance, notebooks files are JSON format. So there's a lot of noise in there, so they wanted to just take what the content of the cells, for instance, the metadata, and just keep it in a database. So that's what Matroskin does for you. It's pre-processing. And then outputs the metrics. In terms of stylistic analysis, Python has a style standard. It's called PEP8. There are linters that are baked in the IDEs that you use, like VS Code or PyCharm, as well as available in standalone tools. So for this, the team used Hyperstyle, which implements Flake 8, WPS, and PyLint. Note that for notebooks, it was easy to use as they just took PyScript and applied it as a cell content, if you will. So the workaround was very easy. And then we have the structural differences. We have the 15 metrics. So if you look, there's code writing metrics, so source line of codes, extended comments. So these are the comments that are in markdown cells combined with the comments in the standard code cells. They're looking at functions, So API function, built-in functions, they're looking at code complexity like function coupling. And for notebooks, they're looking as well as cell coupling, average of common elements between the cells in the notebooks. So these gave them some information, and here's the result. So essentially, notebooks, they have more source line of codes. More source code means potentially more errors. Less blank lines, because things are separated by cells, so you kind of organize your code differently. More comments, it's more commented. It also uses more built-in functions. It uses fewer user-defined functions that's seen in previous research, but they use those more frequently when they do. They also import less functions. For instance, there's always pandas, or most of the time pandas, in such data science projects, but we can think there's only a subset of functions that are used. In terms of complexity in couplings, we can see that they're less complex, but they are more entangled, so this makes notebooks potentially more difficult to refactor. In terms of the stylistic difference approach, so what they did is they identified all issues with hyperstyle in all the notebooks and PyScripts. They identified a total of 600 issues. They classified those in 3 categories that we will see, and they analyzed the top 5 errors for each. What this gives us is a 1.4 times amount of issues in notebooks versus scripts. Okay, if you look at that, you can see 41% versus 2019, 75% versus 40. So you can see there's drastically more errors. But you see a lot of those errors can be attributed to the usage of notebooks in data science, which is like fast experiments with lots of iterations. For instance, here you have a module imported but unused. This is typical in a data science notebook. And since it's not code that usually is going into production, like a Uber app, for instance, well, it's not revised the same way either. But all errors are not equal here. Some of them, for instance, you look at the found statement has no effect, or statement cease to have no effect. That is a lot of those versus scripts. Well, for instance, think about a data frame. Data frame, you go dataframe.head, that gives you a result of just a print of the top 10 instance of the data frame. This is useful when you use a notebook, but from the linter's perspective, it doesn't output anything. So you have to take these with a grain of salt, some of those. So finally, Python notebooks are simpler, but they are messier. Traditional linters, well, they misinterpret notebook practices. We just saw that. And one of the conclusions is that we need notebook-specific tools. In terms of contribution from the authors, if we summarize here, big datasets, 2 datasets for notebooks and scripts, a library for structural analysis of notebooks, and these large-scale comparisons. Thank you. Any questions?